Start recording. And today's is going to be a little bit free flowing. I want to go back and forth with everybody. There is one slide left in the PowerPoint about respiration and photosynthesis. But I do want to, we probably will have to repeat respiration a little bit because you may remember we repeated photosynthesis a number of times too to go over it. But before I get there, announcement. We're going to have a quiz on Friday. Okay. So this is going to cover anything from the last test. Now, PowerPoint wise, this is definitely different than the first test because we had the videos on wound repair. We had a little bit of material that was lecture 3 material that came after the test. So there were some things on tissues, which led us into wound repair. And then coming back from, was it right after spring break? I think that we started into photosynthesis and respiration. And so while we have a PowerPoint on that, a lot of what we've covered was actually covered on the board. So I have not had a chance. I will today, I promise, even if I'm here after 2 p.m. I will make sure that all of your videos are put up so that you can put them on like 2.0 speed and speed through them. Or just do what I do sometimes. Forget what I'm saying and just slide through and watch what happens on the board. You don't have to sit and listen through it all again if you don't need to. But if you didn't have notes from the stuff we covered that was on the board, the videos will be up today sometime. So what that leads us to is I would like to think about scheduling a test about a week out. So maybe next Friday or the following Monday, I think will work. It's not Easter, is it? I don't think so. Yeah, that's right. I don't think the following weekend is like the 8th, 9th, something like that. So I think we'll be okay. Just be thinking, because I'm not sure what other classes and stuff you've got going on at that time, assignments. So just be thinking. So quiz this Friday, and we'll talk about when to have the test. Okay, because that'll be test 2 out of 3 plus the final. Okay, so what I want to cover in this slide, and I'm going to move my thing over here. Is that we have talked about this, basically this line right here, and of course the thing's in the way. This line of material, not the stuff on the outsides, this line of material right here. So look at this. Let's say that we eat a complex carbohydrate. Let's put a name to that. Okay, you go to the kitchen. You're going to fix yourself a complex carbohydrate. What might you make? What do you think that would? What do you think would be a complex carb? Any ideas? Okay. What's a carbohydrate? I'm going to go to YouTube and pull up the Jeopardy theme song. Okay, sugars and stuff. Let's go to the and stuff. Okay, because sugars are not complex carbohydrates. How do I know that? The smaller the carb, the sweeter the carb in a lot of cases. Okay, so let's think about this. We're not looking at sugars. We're going to talk about sugars because they come next. Okay, and we'll talk about why. So what we're getting into is an aspect of our digestive system that we talked about in our anatomy side of things. So what would be a carb that's not sweet? Yeah, give me an example. Pasta. Okay, So pasta could actually be a complex carb. Pasta. So what's a word that you might associate with things like pasta? It's a what kind of food? If you were to give it an adjective that deals with it being a carb, what might you use? Oops, not having enough space there. Starts with S. Starchy. Okay, it's a starchy. I use the adjective here. Hey, Adriana. Hope you can hear us.
We're talking about noodles.
We are talking about noodles. I love me some noodles. Asian food is amazing. Pasta, like Italian food is amazing. I mean, it's just all.
I found out what to go get and maybe I'm not.
Now, let's add some other complex carbs to this.
What about bread?
Okay, breads can be, okay? Especially if you have things that are whole wheat breads, the whole wheat pasta, whole wheat bread, those are actually going to be more complex than some of our more refined straight white flour. Now, while those are still starches, they're not as healthy, okay? One, because they break down so fast. So like eating white bread, like, you know, bunny bread, something, whatever. I love it. But it breaks down to sugars really, really fast. Okay. So whole wheat bread, whole wheat pasta. You can eat things like oats. So if you make your own oatmeal. What about rice? Yeah, right. Rice would be a carb, the starch. So when we think about starchy things, it's totally doesn't fit like I would like it to. But we have pasta, whole wheat, bread, rice, starch. Sometimes I remember in high school, football players were sometimes told to eat starchy foods to kind of get ready for the game at night, like on Fridays. Why were they told to eat starchy foods? Have y'all heard that before? It doesn't break down as fast, therefore it gives an extended amount of energy over a longer period of time. Potatoes are another example. Now, I'm going to add another one up here because basically wheat, rice, potatoes, corn, and then there's a fifth one that I'm not sure if y'all are going to be very familiar with. Cassava. Have you ever heard of cassava? Also called manioc or yuca. Any of those sound familiar? Maybe not because we don't eat them commonly here. We do actually eat them. Have you ever had boba tea? Those are like boba pearl thingies in it. Those are things made from tapioca flour. Tapioca flour is made from these things right here. So another name that you might hear is tapioca. So tapioca flour is common. So these things here, notice I got 1, 2, 3, 4, 5. These are the, hold on, 1, 2, 3, 4, 5. This one's wheat here, okay? So all that's made from wheat. These are the 5 staple foods on our planet. So if you were to look and see what people get the most energy from, it's going to be one or a combination of these foods. Okay. These are the main 5. When I say staple foods, these, you know, does that make sense? Have y'all heard that term, staple foods? These are the foods that Like if you think about every meal that we eat, we have these usually, don't we? Unless you're on a keto diet. And we're going to come back to keto later because keto is going to not use this. Now, we're going to look at how it does work a little bit. So these are the 5 staple foods. And I would like you to know those because these are important. Because when these foods aren't being produced around the world, we start talking about famines. And current events, there's already starting to talk about famines right now. Has anybody heard any talk like that? Can you imagine why we're talking about a famine right now in terms of food? Maybe not in the US, but in other parts of the world. The war, okay? Russia and Ukraine are both large producers of wheat, okay? And while I don't know that we import much of their wheat, I don't know the details of that. I know other countries do. Right now is planting season. And without planting season, if you don't plant, you have nothing to feed people with later. Okay, it's hard to plant in the middle of a war, especially when you plant it and somebody comes by and destroys your field. But do you see why it's so what matters a lot? Like you can look at an economic standpoint. So, hey, business people, this is a connection where business comes in and looks at like what runs people. Okay, if you don't have the staple foods, then those are the things that run the body. But if you don't plant them, or if they get destroyed, or who knows what happens. I mean, you could have a drought, you could have some kind of disease that destroys the crop. Those things will affect the population. It's going to affect prices around the world. And we see a place where you have economics and biology all coming together. Okay, so let's get back to the biology though. Do you see why I'm getting into this point, why it's so important? Because these are the foods that we run our bodies off of. These are the foods that we almost always have with our meals. Okay, we eat spaghetti, we've got pasta. We make a sandwich, we've got bread, rice and beans. What about beans and cornbread? Can't live without mashed potatoes at some point. So good. Baked potatoes, French fries, waffle fries from Chick-fil-A. So good. And for me, because I have actually eaten quite a bit of cassava and manioc, I love me some fried manioc. It is so good. There are days I would prefer to have it over French fries, especially with garlic salt on it. It's so fantastic. And there's a lot of other good food that we make from this. Now, if you are gluten-free, a lot of gluten-free bread recipes use this flour, the tapioca flour, along with some other ones, but oh, it's so strong. So we talk about carbs, complex carbs. That's what we're dealing with. Those are the kinds of foods we're talking about. Okay, so let's get back to our digestive system. So we've got a complex carb. Make sure I'm on board here. Let's just go with the pasta since it was the first one. It breaks down into a simple sugar. Now, how does it do that? So this is our digestive system that we're going to get into here a little bit. We saw this with our salamander this week. We eat the food, we chew that food up, right? We actually start the breakdown in the mouth. So we have two things that happen in the mouth. We have mechanical digestion. Mechanical, I'm not sure if that's actually on the board or not. I can't see it. Mechanical digestion. We're also going to have chemical digestion happening in the mouth. Carbohydrates start being broken down in the mouth. Did y'all know that? Have you ever chewed a piece of bread and it just kind of starts to disappear? Yeah. Okay. Now, where does it go from there? The mouth, down the esophagus to the stomach. And in the stomach, we get breakdown of both. We continue breakdown of carbs, but then we start proteins. Okay, and we're going to come back to proteins. Right now, we're going to stick with the carb. Okay, where does it go from stomach? We get into the small intestine, which continues breakdown of carbs, continues proteins, and then we start to break down lipids. We're still focused on carbs now. We will come back to the other stuff. Okay, now where does it go from small intestine? Oh, forgot one thing. So not just breakdown. So there is a breakdown. Absorption. So you remember the villi, the surface area where we cut open the small intestine and we looked at it and it increases the surface area so we can absorb all of those nutrients. So we took this big, large carbohydrate and we've eventually gotten down to something like glucose. Because that's all a starch is. A starch is just a big long chain of a bunch of glucoses or mannoses or fructoses. Y'all see what I'm getting at? And now at this point, it gets absorbed. Where does it get absorbed into? The bloodstream. Where does it go? It goes to the cells of our body. And then what does it do? That glucose goes through cellular respiration, which we just talked about last time, right? Okay. Because what does cellular respiration give us that we need? ATP. Because if you don't have ATP, you die. So how does this fit into the diagram that I'm getting into here? So if you follow this diagram down, we have complex carbs like our pasta. The digestive system kind of process takes place in this little arrow here, doesn't it? On the board. And then we've got simple sugars like glucose. And then once we have glucose, we can do the cellular respiration process where glucose ends up becoming pGal through glycolysis, our first step of respiration. We make pyruvate from that. Then we go through the acetyl-CoA, making the Krebs cycle. Y'all notice that the carbon dioxide is given off here. And then we do the electron phosphorylation or the electron transport chain, and we end up making lots and lots and lots of ATP. A little bit along the way, though. So a little bit at the end of glycolysis, a little bit here at the end of the Krebs cycle, and a whole lot at the end of our electron transport chain or electron transfer phosphorylation, whichever you want to call it. How much do you make total? How much ATP total from one glucose? Do y'all remember from finishing it out Monday? Total a net with a net of 36. It's actually 38, but we have to use some of it back in glycolysis to get glycolysis started. Okay? How are we doing? Is it making sense? So this is what we do. When we eat those complex carbs, when we eat those 5 staple foods that we use around the world, those things go through the digestive process, which we worked our way through. And that's what we do. We digest from the mouth, go to the stomach, small intestine, we break down, absorb bloodstream cells, cellular respiration, we make ATP, and we can power our bodies. So why does keto diet work? How do you not die from a keto diet? Because obviously, what's the point of keto? high fats, high protein, as low as you can get them, basically in terms of carbs. So what I've just described here is all about carbohydrates. So why does a keto diet work? Okay. Keto diets restrict the amount of carbs that go into your body so that we don't do this very efficient process. Okay, well, what do? Can we make ATP from things that are not carbohydrates? And that's where the rest of this diagram takes us. Okay, so we have, let's say fats. You mentioned fats first. So fats can be broken down into two things. So there are let me say lipids. Lipids can be broken down into two things. They can be broken into fats, fatty acids, and glycerols. Those are the two like small components. Just like glucose is a small component of a big starch, fatty acids and glycerols are the kinds of things that you break lipids down into, fats. Because when you say fat, it doesn't have to be fat. It can also be an oil, right? So lipids of any sort. So let's talk about other lipids real quick. So what are some fatty things that you might eat on a keto diet? What are some lipids that are going to be on your keto diet? It might be mixed with something else, but we can pull out the lipid aspect. Y'all know anybody that does keto? So oil, so cooking with canola oil or vegetable oil, or they probably prefer something like coconut oil or avocado oil or olive oil. Have you ever met anybody who does their own like bulletproof style coffee, and instead of putting milk in it, they put butter? They actually say it tastes pretty good. Okay, I mean,
But like, what is the butter doing there that's better than?
because you're lowering it to the butter doesn't have the same amount of carbs like milk does. It has a higher amount of fat. And what you're trying to do is push your body into ketosis. So instead of putting milk in, they'll put the fat in. Kind of help push that. So it's we get the energy that way. So ketosis is I'm not going to get into that because I don't fully understand it as well, but ketosis is what happens when your body starts to produce ketones, which are a type of protein, to break down fats and proteins. But that doesn't actually happen until carbs are not in the system very much. Okay, I don't think that it's a good idea to stay in ketosis for a long period of time. Okay, one, it's not efficient. Two, I'm not sure that our bodies, actually, I'm pretty sure our bodies did not design ketosis as a way to continually survive. I think it's more of a backup system of, well, if you can't get anything, at least we can get energy from that in terms of fats and lipids. Our bodies are better to have everything kind of interspersed, everything in moderation, right? So I wouldn't stay in ketosis, but I can see how you might kickstart your body, kind of empty the carbs, and then start to break down the foods that we over here that are fats. Now, what that also does, so when you eat things like butter, but not the sugars, bacon. Now, bacon's got protein, but it's also quite high in lipid, right? There's a lot of grease when you cook it. Healthy fats, like you said, the oils. When you do this, when you break these things down, I'm getting chalk all over me. Realize I've got it everywhere. You break them down into fatty acids and glycerols. Look at this. This is interesting. Glycerols can actually go in and do glycolysis. Well, how many ATP are you going to make from a glycerol? 2, 4, 32, for a total of 36. So that's really no different than the carb, right, in terms of ATP production. But what happens if you take the fatty acid side of the fat? Where do you enter the process? After glycolysis, right? So how many ATP are you going to produce? 2 plus 32. That's only 34. So you actually, with fats, you get to some degree less ATP produced. You are forcing your body in ketosis to not have as much energy in the food that you are eating. So where does your body get its energy? You're not feeding it as much energy. Where does it get the energy? What does it have to break down? Okay, let's talk about protein. So you're also giving it protein. Okay, let's look at protein. Proteins over here break down to amino acids. Some of those amino acids can go in and become pyruvates. Some of them go down and goes directly into the Krebs cycle or into the acetyl-CoA and then the Krebs cycle. But you're still skipping glycolysis. So with proteins, you're still making fewer ATP, right? Just like you do with part of the fats breakdown. Okay, so you're getting some energy, but you're still getting less than normal. Why do they say to eat higher proteins in lots of diets, especially keto, but not just keto, but other diets too? What are the purpose of eating proteins? When you eat protein, it makes you feel full, right? And you feel satiated for longer, so you don't eat as much. And so the whole purpose of all of this is to take in less energy so that you make less ATP, fill yourself up the feeling of being full, so you don't go out and eat more stuff. But you still got to have energy to run you. Where does that energy come from if it's not coming from a carb? Oh. What do y'all think? If it's not coming from your food, where else could your energy come from? It's not coming from the sun, right? You're not photosynthetic. You have energy anywhere else that you can access. This is easy. Body fat's one. One is body fat. So the whole purpose of diets are to reduce the fat, right? You have to bring the amount of calories that your body is actually getting. And when we say calorie, I need you to think energy, because calories are actually kilocalorie, but we don't say that in our everyday terms. But it's a kilocalorie. It's a measure of energy that you can put into your body. So the fewer calories or the less energy you put in, but your body still has to run off of that energy that you have. The whole purpose of a diet is to start using the energy that you stored. There are two places. One of those is body fat. Okay. The other one is sometimes stored as glycogen. And glycogen is actually on our diagram here. So fats get broken down, as you see how that works. Glycogen up here acts like a complex carb, because it kind of is a complex carb. Plants store their food sources. So when they do lots of photosynthesis and they store things for later, that's why potatoes have potatoes. They're storing energy for a later time, right? That's the whole purpose of that. So they store it in the form of starch. We, on the other hand, as animals, store ours as glycogen. But we can break it down as a complex carb, just like we would, or I should say similarly to what happens with a complex carb. We can go through glycolysis. So we have our two stored places. We've got our body fat and our glycogen, two places where we have stored excess energy before. And so things like keto diets, you might use this to reduce the amount of intake of energy, to keep you fuller for longer, so that your body takes away some of that extra body fat and that excess glycogen that's stored. What do y'all think about this? Does this help understand keto diets and other diets? Think about, was it the Atkins diet? was the one that was like no carb at all. Now there is a problem with this. Your brain pretty much predominantly works off of glucose to do ATP production. It doesn't really do the other forms with keto very well. So you have to have some carbs. Your red blood cells only work off glucose. So can you have no carbs at all in your diet? Not a good idea. Okay. Does this raise any questions for you? Do you have any thoughts on what's going on in terms of like digestion? Because I don't want to get into the nitty gritty of the breakdown of the proteins. I don't think that's necessary. I would like you to be able to walk away and go, I think I want to start losing weight. How would I do that scientifically? Do you feel like this gets you started to understand what's happening in that process? Do you have any questions? Any thoughts? Like, y'all had some great questions with photosynthesis and the plants and stuff. Just wondering if y'all have anything. Anybody online got any good questions? Brian, Adriana, you may be busy, but if y'all have got questions, chat or just speak up. Was this useful? Okay, I'll propose a question for y'all if you're thinking. Are you familiar with, I think they call it the lap band procedure? The one where they go in and they put this band around your stomach? Can y'all explain to me what that's supposed to do and maybe how it might work?
Smaller, so you eat less.
So-
So you don't have less energy, and so it's kind of the same with keto. Because you have less energy, you start eating away and store stuff like body fat.
Yeah, so you're reducing your calorie intake. And I think the idea is that if you can keep it from your stomach from expanding and taking more food, you feel full. And so you don't eat as much as well. So you've got one, you don't take it in, and you also don't feel like you want to take in more. There are some problems. You can overeat, and that can be really dangerous with those because your stomach really can't expand with that procedure. Yeah, I'm not a huge fan of that procedure personally. So how does something like this, I don't know if I want to call it a diet, but the techniques of just calorie counting, how does that lower body weight?
Less calories than you're burning. So again, just starting off with this sort of stuff.
Yeah, that is exactly what we're trying to do. Every way to lose weight has to come with a calorie deficit. You have to you have to take in less calories than your body uses. It's the only way that you can burn any excess stored energy, whether it's fat, glycogen, or whatever. Most of us are interested in getting rid of fat. Glycogen's not such a big deal, at least not when we think about things. So if I were to ask y'all a question like I've been asking here on the test, could you take your knowledge of photosynthesis and respiration and apply it to maybe an everyday problem? Okay. Let me ask you this. Why would I say that it's good to have a plant-based diet? How would that affect things? Think about a plant-based diet.
Why would that be useful or healthy for people? What are some, now this takes into some other accounts too, but I'd like to know what you think. So plant-based diets, from what you know, what does that have to do with keeping humans alive? By no means. Feel free to throw out problems with, being a plant-based diet. So what are some, maybe what are some issues that, so people who are vegetarian, or if they get a little extreme, a vegan, what are some issues with that? What are some benefits with that based on what we know?
Okay, would an issue be the absence of protein? So I think what Ryan's asking is something we've not talked about, but I think most people have some idea that when you don't have protein, being on a plant-based, completely plant-based diet is actually a problem. There are 8 essential amino acids. This is something I did want to get to. You have to have 8 essential amino acids. And those essential amino acids can be found in meat. Okay. So amino acids, you're like, what's that? Well, amino acids are the small building blocks of proteins. So if you eat protein, you're going to get all essential amino acids if it comes from an animal. The problem, and thank you, Ryan, for bringing that up. I'm so glad you did. The problem with the plant-based diet is there are very few plants that have all 8 essential amino acids in their makeup. So what do you do? If you're a vegetarian or a vegan, how do you get all of your 8 essential amino acids? And when I say essential, I'll put it this way. Basically, your body can't make these. You have to get them from outside. So how do we get 8 essential amino acids? This is going to tie right back into our first 5 staple foods, because none of those staple foods that I showed you have all 8 essential amino acids. So what do you mean? So if it's not meat, what's your other sources of protein? Tofu is a plant. And I see what you're getting at. And in fact, you're right. What is tofu made from? Soybeans. And soybeans are legumes. Okay? Legume plants. So you could do soy. And now soy itself does not have all of the essential amino acids as far as I know. We have to do it in combination. So, well, let me write it this way. Instead of writing the specific one, let me do this. You've got to have a legume and a grain. It has to be a true grain. What's a true grain? Corn, oats, wheat, rye. Forgetting some other ones that are really common. Did I say rice? Rice? And this is where it ties back. Every time, especially if you're vegan, you've got to eat things in combination. Like I said, there are a few plants that have all the essential amino acids, and if I'm not wrong, one of them that does is quinoa. You ever had quinoa? They call it a grain. It's not technically a grain. It's not from the grass family. But a true grain does not have all its essential amino acids. So think about this. You can eat soy and rice, and that would give you all 8 essential amino acids and keep you on a plant-based diet. Can you think of some other essential meals around the world that combine legumes and grains? So legumes, soy is a legume. What are some other, okay, legumes are bean, pea, those kinds of plants. So what are some combination foods that you may be familiar with?
So a legume and a grain. We talked about soy and rice. What else? Oh, we eat stuff like this all the time here. You live in Mexico or basically anywhere south of Mexico too, what's going to be the staple like meal most days in the week? Any ideas? Not the rest, not necessarily south of Mexico. I mean, yeah, some places south of Mexico. I'm asking you to think legume and a grain, legume and a grain. What combination is going to be a legume and a grain? So I gave you some examples of legumes and grains. What are some really common combinations of that? You're going to eat poor people's food. I'm going to call it poor people's food because it's a cheap meal, but it keeps people very healthy. How about red beans and rice? Good point, Adriana. Now, it won't be red beans, and most likely when you go Mexico and South, but it's going to be a type of bean of some sort. A lot of times it's like pinto beans and rice. Maybe it's a black bean and rice. You go to Brazil, they have a wonderful thing called feijoada. Now it has meat in it, but their regular meals during their week. A lot of the poorer people I know in Brazil, they eat meat once a week, and it's usually beans and rice. And I'll tell you, it doesn't matter if you're poor or rich, beans and rice is going to be in a meal if they have a choice. Okay, doesn't matter if you're in El Salvador, doesn't matter if you're in Brazil, Mexico, beans and rice is going to be really common. Now, we do beans and rice here too. Red beans and rice is a good example. I think as you go further up into the South, red beans and rice becomes less of a common food. We eat it, but it's not like a staple. Can you think of some things that we eat here? Maybe, I don't know. I'm just going to say it. Could nobody eat like beans and cornbread? You don't like cornbread, but you know about it, right?
Yeah.
Beans and cornbread. Come on, Tennessean. Come on, fellow Tennessean. We know this stuff. You may not eat it, but you probably see it all the time. My grandmother would go to the restaurant. She'd walk down the street to a restaurant, and she'd order a bowl of white beans and cornbread, and that was her lunch. So good.
My grandma makes cornbread with everything. Cornbread is some kind of bean. Brown beans, white beans, and that. But
Yeah.
my family doesn't really eat the cornbread things. They eat cornbread buttermilk.
Oh, that's good too.
So that's
Yeah.
why I didn't think about it.
Yeah, my family does too. But just because you eat it, here's the thing, you don't have to eat them together. You might eat the beans for lunch and the cornbread for another meal, but you got them in the same day. Does that make sense? They don't have to be necessarily together. But commonly around the world, a lot of our low-cost diets that are very healthy, and this reason right here, these give us all of our 8 essential amino acids. So beans and cornbread, beans and rice. Okay, soy in case of tofu. Or if you want to eat edamame, which is basically just good soybeans in their pods. But you could eat peas. How about hummus and pita bread? Hummus is made from chickpeas. So that would be another part of the world, kind of another diet that you might see. You see how common we do this combination. Peanuts are legumes. Peanuts are not nuts. Peanuts are actually beans or peas, whatever you want to call them. It's the pea part of the nut, not the nut. So a lot of good protein powders that people will use will be peanut based, unless you have an allergy, then don't do that. You see what I'm getting at? That's really cool. So thank you, Brian. Thank you, Adriana. Thank you for Shelby and everybody else who's here, which is all 4 of you. Covered you all this one. So what do y'all think? Interesting? Useful? Think you could live off beans and rice? Absolutely, you could. Would you enjoy it? I would.
Yeah, you can live off of it.
You could live off of it.
There's so many different combinations of these.
I think so. You could, I mean, I'll tell you, depending on the country you go to in Central and South America, you have different beans. And so like you have all kinds of different beans that you could put together. I think about like cowpeas and stuff around here, or purple whole peas, black-eyed peas. I could do this. So this essential 8 amino acids, I'm so thankful that you went there, Ryan, because that's where I wanted to go eventually. I'm hoping this kind of helps y'all see a little bit of the digestive system, some of the nutrients that goes in and how that fits into this cellular respiration. And we could even take it back to photosynthesis because they're what produced those plant-based foods. Okay. Yeah, there's a lot of combinations. Even oatmeal could be your meal in the morning, and then you have a bean or pea throughout the day. Those are combinations that would work. And you may even come across more. Maybe you, as you learn about other cultures, you see other combinations of ways of getting these essential amino acids. These are the most common. It's not the only way to do it, but it's the most common because between these two, you get all 8 essential amino acids. Okay, so repeat, Friday, we'll have a quiz to the material up to this point. I will get videos up hopefully at some point today. Okay. I've been meaning to do that last week, to get last week's, and it just slipped my mind. I'm sorry, guys.
So
Okay.
it's 3D and the room prepare and this.
Yes, I've tried to, not all, I've tried to put all the videos in the
Yeah.
next one, but
Under testing.
yeah, under test 2. I've tried to do that. But some of that had one PowerPoint that was slightly across both test 1 and test 2. So I've tried to separate there.
Yeah. it was-
Okay. Okay, I'm gonna let y'all go. Hopefully, if you have any questions, let me know, okay? And we'll be having a test probably sometime next week. Think about when's good for you. Not Monday. It won't be Monday for sure. Okay, I'll see everybody later.
Bye.